Hi students, this is Mr. Yang. Today we are going to finish the last bit of row reductions. But first, let's review what we have learned several lessons ago, which is how to use the formula to find the inverse of a matrix. First step is to find a determinant. So the determinant of this is going to be the one diagonal subtracting the other diagonal. So that is going to be negative 2 times 3 minus 3 times 4, which is negative 18. That's the first step. Second step, I'm going to need to make a new matrix. The new matrix is generated by first swap one diagonal, so 3 here and negative 2 there, then change the other diagonal into opposite numbers. So negative 3 here and negative 4 here. Last step, we are not going to just use the determinant, we're going to use the reciprocal of the determinant. So 1 over negative 18, multiply it with this new matrix, 3, negative 4, negative 2. That is going to give us a result of negative 1/6, then a positive 1/6, a positive 2/9, and a positive 1/9. That's question A. Question B, let's repeat the same process. First, find the determinant, one diagonal subtracting the other diagonal. So 12 times negative 6 minus 8 times negative 9. This is where a lot of you may need to be very careful with the negative signs. That's negative 72 minus a negative 72, which becomes positive. So that gives us a 0. When the determinant is a 0, we can't find any reciprocals. So there is no inverse in this case because determinant can't be 0. That is question B. So we have learned to use a formula to find the inverse of a matrix. And in the last lesson, we have learned how to perform row operations. So today's lesson, we are going to combine them. The formula didn't just come out of nowhere. The formula actually came from a row reduction method, and it's just a simplified method. But the row operation is why we can actually find the inverse that way. So today we are going to learn how to use row operations to find the inverse of a matrix. We are going to set up an augmented matrix formed by the given matrix and an identity matrix. So here's how it looks. This is whatever matrix we are given. We're going to form an augmented matrix and put the identity matrix inside that same one. Now here's what could happen. If we actually multiply both parts by the inverse, the whatever times itself is going to give us a 1, which basically is going to be the identity matrix. And as for anything times the identity matrix, that's going to give us the inverse. So without looking at the middle part, it is basically changing the matrix into the identity matrix, then the identity matrix would automatically change into the inverse. In words, this means our goal is to use the row operations to change the left matrix into identity matrix. Then the right matrix will be the inverse. This process is actually quite similar to what we learned yesterday, because our goal yesterday was to get from A and whatever resultant the answer matrix may be, trying to get that into 1, 0, 0, 1. Then these numbers that we got at the A and B would be our answer. So today, as you may notice, we are also changing that A into identity matrix, and then the right side would be our answer. So let's have a look at an example. First, we are going to need to generate the matrix we are going to be working with. Write down the given matrix 7, 5, 4, 3. And then we are going to need, that's a 2 by 2, so we're going to need a 2 by 2 identity matrix. 1, 0, 0, 1. Next, I'm going to write our goal on the top. Our goal is to get it into 1, 0, 0, 1 on the left. The right would just be whatever it is. And that's going to be our answer for the inverse. So here, our first thing we need to do is to make this 7 into a 1. Whenever we need to make that number, any number in the matrix into a 1, the best way is to multiply by its reciprocals. In this case, I'm going to multiply my first row by 1/7. That's going to change my first row. 7 times 1/7 is a 1. 5 times 1/7 is 5 over 7. 1 times 1/7 is 1/7. And 0 times 1/7 is a 0. My second row will stay the same. Next, I already got my 1, so it's time to move on. I'm going to make that 4 into a 0. Recall, whenever we're trying to make a 0, we need times row add. we need to multiply the other row by something, then add on to this row so we can make a 0. In order to make a 0, the number is 4. In order to make a 0, we need a -4. So here's the thing, if you still haven't noticed, whenever we need to generate a 0, the other row that we're actually using are always going to be a 1. So we can always just multiply by the opposite number of what we're trying to get to. We're trying to get a 4, so I'm going to multiply the first row by a -4, and add on to this second row. So my first row is not changing, 1, 5, 7, 1, 7, and 0, but I'm going to multiply everything by a 4. 1 times 4, by a -4. 1 times -4 is -4 plus the 4 is a 0. 5, 7 times -4 is -20/7. And plus a 3 is going to be a 1/7. That's calculator work. And then 1/7 times -4 is -4/7. Plus a 0 is -4/7. Last one, 0 times -4 is a 0. Plus 1 is a 1. I mean, not a, yes, it is actually a 1. Now, we are done with the 1 and the 0. Now it's time to change that 1/7 into a 1. And if you recall, I just said it like 2 minutes ago. Whenever we want to make a 1, we are going to need to multiply by the reciprocal. That is the fastest way. So I'm going to multiply that 1/7 by a 7 on the second row. So my first row stayed the same. But my second row, now everything is being multiplied with a 7. So 0, 1/7 times 7 is a 1. -4 times 7 is, over 7 times a 7 is -4. 1 times 7 is a 7. Lastly, we just have one more number we need to change. Now we need to change that into a 0. And again, whenever you want to change it into a 0, if you still haven't noticed, the other number would always be a 1. That means we can always multiply by the opposite number of the one we're looking at. We're trying to change. So I'm going to multiply the second row by -5/7, row 2 plus row 1. That means my row 2 is not changing, but my row 1, first position is got to be a 1. Second position, well, we're trying to get a 0, so it's got to be a 0. Next, 1/7, well, -4 times -5/7 is going to be 20/7. Adding on to a 1/7, so it's 21/7, which is a 3. And lastly, 7 times -5/7 is -5, plus the 0 is -5. So that means this is what we're trying to get to. So the inverse of A would be 3, -5, -4, 7. That is example 1. It may be a longer process, but remember, the formula comes from row reduction. This is also good practice on yesterday's lesson. So we are going to need to know how to use row reduction to find the inverse. Next, example 2. Let's write down the matrix first. 3, -2, -3, 4. 1, 0, 0, 4. I mean 0, 1. Let's get to it. First, we are going to need to make a 1 in the first position. That 3 needs to be a 1. So multiply the first row by a 1/3. That's going to give me 1, -1, 1/3, 0, -2, 4, 0, 1. Next, we already got our 1 in the first position. It's time to get our 0. That -2 needs to become a 0. Twice of the first row is the opposite number, then adding on to the second row. So that means my first row is not changing, 1, -1, 1/3, 0. And the second row is going to be -2. Well, sorry, it's going to be a 0. And the -1 times 2 is -2 plus 4 is a +2. 1/3 times 2 is 2/3 plus a 0 is 2/3. 0 times 2 is 0 plus a 1 is a 1. Next, we already got our 1, our 0. Now we need a 1. So I'm going to multiply that row by 1/2, the reciprocal. So we have 1, -1, 0. 2 times 1/2 is 1. And then the next part is 1/3. Well, the 2/3 times the 1/2 is going to be a 1/3. And I forgot the first row does not change. And the 1 times 1/2 is a 1/2. Lastly, We have the 1, the 0, and the 1. We just need this to become a 0. So row 2 add on to row 1. Because the coefficient is just a 1, so I don't have anything I need to multiply. So I just simply add row 2 to row 1. That means row 2 does not change. But my row 1, that stays. This is going to become a 0. 1/3 plus 1/3 is 2/3. 1/2 plus 0 is 1/2. So that means the answer would be 2/3, 1/2, 1/3, 1/2. That is the matrix, for example, and the inverse, for example, 2. Moving up, example 3. Start with the matrix, -8, 6, -5, 4, 1, 0, 0, 1. Same process. Let's get going. First, this is going to be quite a bit more fractions, but it's the same idea. First, we need that 1, so we're going to multiply by the reciprocal, -1/8 r 1. So got a 1 there. -1/8 times -5 is a positive 5/8. And then the right side, -1/7, and not 1/7, 1/8, and then a 0. Copy down the second row. Next, we need the second row number to become a 1. So I'm going to multiply everything by a 1/6. So we have 1, 5/8, -1/8, and 0. And now we're going to change the second row. So that's going to become a 1, and not a 1. Oh, I just realized I shouldn't actually do that. What I'm trying to accomplish is actually to get a 0. So I'm going to need to use the times row add. So I'm going to multiply my first row by a -6, R1, then adding onto a second row. First row stay the same, 1, 5/8, -1/8, and then 0. All right, that's going to get me a 0 here. 5/8 times -6 is a negative 15/4. Plus a 4 is going to give us a 1/4. And then the 0, well, that one, -1/8 times -6 is a positive 3/4. Adding a 0, 3/4. Lastly, 0 times whatever, then plus a 1 is going to stay a 1. Now we need to actually have that one turned into a 1. So multiply that row by a 4, the reciprocal. So we have 1, 5/8, -1/8, and 0. For the second row, 0, 1/4 times a 4 is a 1, 3/4 times a 4 is a 3, and 1 times a 4 is just going to be a 4. Lastly, we are trying to change that 5/8 into a 0. So I'm going to multiply my second row by the opposite number. Again, it doesn't matter what kind of number you see. It doesn't matter if it's a fraction or a whole number. You are going to use the opposite number, multiply by the other row, then add on to it. So row 2, then add on to row 1. Copy down row 2. And if we multiply all of these by -5/8, that's going to give us a 1. That's going to give us a 0. The other two numbers are what we need to try to figure out. -5/8 times a 3 is a -15/8. Adding on to another -1/8, that is going to be 16/8, which is a 2, -2. And then the other one, 4 times -5/8 is -5/2. Then plus a 0 is going to be a -5/2. Oh, actually, not a negative. I just realized. Oh yeah, it's yep, it is -5/2. So that is the inverse. Now we can write down the final answer. My C inverse is going to be -2, -5/2, 3, and 4. That is my answer. Last one, example 4. Let's write down the matrix that we need. 2, -1, -3, 6, 1, 0, 0, 1. First step, we are going to need a 1. So multiply that row by a 1/2. 1/2 of the first row, that is going to give me 1, a -1/2, a 1/2, and a 0. Second row does not change. -3, 6, 0, and 1. Now it's time to make that 0. Make this into a 0. So multiply the first row by the opposite number, 3r1 plus r2. So we are going to get r1 does not change, 1, -1 half, 1 half, 0. So 3 times 1 plus -3 is a 0. -1 half times a 3 is -3 halves plus a 6. That is going to be a 9/2. 1 half times 3 is 3 halves, plus 0 is 3 halves. 0 times 3 is 0, plus 1 is a 1. Next, we already have our 1, our 0. Now we need this to become a 1. So we are going to multiply by the reciprocal, which is 2/9 of r2. R1 stayed the same. R2, however, that's a 0. That's going to become a 1. 3 halves times 2/9 is going to be 1/3. And 1 times that is going to be 2/9. Now the very last step. Now we need this to become a 0. So that's a -1 half. That means I need the other row to multiply by a positive 1 half. Then add on to the first row. So that means I am keeping my second row 0, 1, 1/3, and 2/9. As for the first row, well, that's going to become a 1. 1 times 1 half plus -1 half is going to be a 0. 1/3 times 1 half is going to be 2/3. And that, well, it's 1/6. That's being added onto 1 half, so it's got to be 2/3. And the last number, 2/9 times 1 half is 1/9 plus a 0, still going to be 1/9. That is example 4, and hopefully now you may realize that this is kind of the same as the row operation we have learned to solve equations. That concludes the first part of today's lesson. I will finish the second part, which involves calculator, in another video. Thank you.